And thank you all for your attendance. So I'm going to tell you more about this story. We started in 2008. In 2008, we were the two of us, Philippe Marlière, a visionary scientist in this field of what we call industrial biology, and myself, I'm a scientist as well, more on the execution side. My job is in fact to make things happen, create companies, raise funds, organize the R&D, and organize the business development and the market access. So I'm going to share a slide deck with you, which will tell you in some details about this company we started 12 years ago. So okay, could I have a confirmation that you see my screen?
Yes, we can see it.
Okay, thank you. So 12 years, it's a long time for a startup. So I'm going to tell you about where we are today. And today, the very high priority is to reach the market. We've done a great journey in terms of science. I'm going to tell you about this. We've done a lot of things in industrial development, but now it's time to bring our story on the market, and we have developed a strategy on this, and I'm going to explain this all the phases to you. So we are a listed company, so I need to show you these slides saying that there is no responsibility from the company if there is some misleading or fuzzy information in there. So what are we doing here at Global Bioenergies? We're doing, in fact, only one thing. We're producing isobutene from renewable resources. So isobutene is this molecule you see on the upper right. So it's a 4-carbon molecule. Global Bioenergies is so much associated to isobutene that day one we made our logo. We designed our logo from the chemical formula of this molecule. So bioisobutene or isobutene is a name that does not ring very familiar to most people. It's not known from the public. It's a building block of the petrochemical industry. So from oil, you steam crack oil, and you produce isobutene, and from there you use this isobutene to produce chemicals or fuels that are used in the everyday life. So isobutene is everywhere. It's in the tank of your car. It's in the plastics that are in your at your home. So there is isobutene everywhere, but people do not know it. And what we are doing at Global Bioenergies is producing the same molecule, the very same molecule, but from renewable origin. So not from oil, but from sugar beet, sugar cane, from cereals like corn or wheat, and also from agri waste and forestry waste. And one thing should be said about how we do that. So we do that using bacteria that we have deeply engineered. So there is a new name in the industry talking about deep tech. Some people consider that Global Bioenergies is a deep tech company. So it means that it's not a small effort we've done on the process. It has really been a huge effort to develop this process from scratch, from the idea we had at the beginning of the company, a 4 pages synopsis, and we developed a process whereby bacteria are converting sugar into isobutene. Bacteria do not do that in nature. In nature, isobutene is not produced. It's only produced from oil as of today by the chemical processes based on oil. And today, for the first time, we are producing isobutene from sugar by using bacteria that we have engineered. And because isobutene is not produced in nature, you don't have enzymes that are producing isobutene. So you need to build a complete metabolic pathway. And so this has been a huge scientific journey, 12 years, and it has we have spent over 100 million euro to build this process. We have generated a lot of IP rights. We did a lot of test and learn approaches to improve the various aspects of the process. And today the process is there. It can still be improved, and we still have efforts in the lab to improve this process. But it is already in exploitation. You see that in the lab we had a small fermenter. Like the largest fermenter we have at lab scale is 42 liters. Then we built a pilot plant in 2015. And in 2017, we built a demo plant in Germany. So our pilot plant is on a sugar platform based close to Reims in France. And our demo plant is on the site of a petrochemical site with all the safety instruments that are necessary to steer that kind of process. And this demo plant is in operation since 2017. So we had a lot of ups and downs. We have it's been a tough day to go from the little team of scientists we were in 2012 to people able to manage and operate a semi-industrial site. I say semi-industrial because in fact the first markets that attracted our attention were biofuels. The promise of isobutene in terms of market application is that if you combine molecules, 2 molecules of isobutene into a single molecule, which is named isooctane, you have the perfect gasoline. It means that this molecule, isooctane, which rings familiar to the ear, isooctane rings octane rating, and in fact it's the best molecule, the molecule having the highest octane rating for gasoline engines. And the promise was to produce real gasoline, not ethanol, not ethanol, real gasoline from renewable resources. So that's our first vision, and we did a partnership with Audi, the car maker, and we did a lot of things, including road testing on a circuit close to Paris, which using gasoline that was produced from our demo plant. So our demo plant in operation was used to produce isobutene, eventually isooctane, and then used for road testing. But the problem was that the price equation was not really there. And so we looked at what we could do additionally. Jet fuel is a little bit higher in terms of price if compared to gasoline. So we were able to produce jet fuel from this isobutene. By combining 3 molecules of isobutene, we get a larger molecule, 12 carbons, and this is perfect for jet fuel. And so we did some regulatory efforts, and we have this project to bring to life at some point a jet fuel industrial path, so that we can create less emissions when we use airplanes. Why is that? It's because in fact when you use renewable products like this one, it's no longer a one-way trip from the underground to the atmosphere. This is the oil industry. You harvest oil in the underground, you burn it, and then it creates CO2. So in the case of renewables like the ones we are talking about, it's no longer a one-way journey, it's a cycle. So the plants, for example, the sugar beets, are harvesting CO2 from the atmosphere. That's photosynthesis. We use this CO2 to produce the fuel, which is burnt and recreates CO2, ready to be harvested by the next generation. So it's a cycle which produces much less CO2 if compared to the oil pathways. And so we pushed this jet fuel opportunity, and again, not a huge traction because the price equation was not there yet. Our production was too small, in fact, to be really cost efficient. And so we looked at what we could do with this isododecane, and it happened that this isododecane is used quite massively in the cosmetics. So we started a collaboration with L'Oréal in 2016, and many other players in the cosmetics have tested this isododecane, and it's okay, works well for this for the various cosmetic applications that we can think of. And I'm going to tell you a little bit more about what we do today in the cosmetics. So first, everyone wants green cosmetics. Everyone wants to get away from oil. That's clear. You can read this in all newspapers. Here it's French language, but you have the same in the UK, the same in the US. That's the market of cosmetics. 5 big segments, and isobutene derivatives are used pretty much in all of these segments. But today I'm going to tell you more about the makeup. In the makeup, you have 3 segments: eyes, lips, and skin. And you have and you also have makeup removers. And you have 2 modes. One mode is normal, and it's pretty much water-based makeup. And the second is long wear. So you don't have to take care of your makeup for all the day, during all the day. It's about 25% of the market. It's oil-based. It corresponds to different types of people, businesswomen, wet geographies, outwear. And you see that for in many products from this long wear makeup type, isododecane is the first ingredient. Isododecane, first ingredient. In fact, it's the oil of this of all the long wear makeup. It's the base of the formula. It's about 25 to 30%, 50% in some cases, even 85 in some cases. So it's the oil, and this oil has specifics in terms of characteristics. It needs to be volatile. It needs to be a good solvent. There is no way it can be another product. It needs to be isododecane, selected by 100 years of chemistry. And so what we did is that we created the first range of products that are both long wear and natural origin. We did all the prototyping, so you see products, mascaras, lipsticks. So we did the prototyping. We did the regulatory. We talked to various tollers that can produce these range of products, and today we announced recently, 1st of March, we announced that we would launch our own range of makeup products within 6 months, meaning before the 1st of September. So for the first time, we will have a combination of naturalness and long wear performances. So it's a market segment which represents about 1,000 tons of isododecane. And for the first time, and what we see is that we have the potential to move this segment from oil-based to renewable. And here, what we see in the market is that the price equation works well. We can absolutely address this market with the right price equation. And so that's our market entry. What we're going to do is to bring this unique range of product in Q2 or Q3 2021. we will have a very unique and solid claim on this large market. Some risk, but no real barrier. So we've done it. A lot of things have been done already, and we have the possibility to scale up and to become an indie brand in the cosmetics, and then to move as an ingredient provider, so that the innovation goes everywhere in the cosmetics. And then, of course, this 1,000 tons market it will be followed by another market in the cosmetics, which is much broader, and in the skincare and the hair care, about 100-fold broader. So as a second step, we will conquer this larger market, and then eventually we will harness the biofuels opportunity. We are still going after the let's do biofuels instead of oil-based fuel to save the planet, and our journey in the cosmetics is a way to access, a way to scale our process up and access this huge market of biofuels as a second step. So that's our vision. The cosmetics is going to be the first, the launch pad for a much broader journey toward a better world. Thank you very much for your attention, and I'll be pleased to answer any question if you have some.
Wow, Mark, thank you. Thank you very much. For regards questions, there's the chat line, and then there'll be the opportunity at the end for me to raise questions that have been posed via the chat to you directly. I'm not actually wearing a hat, but I'm going to make the gesture. Chapeau. Hats off, really a fantastic story. And I'm sure many of your listeners will be familiar with your website, will have read about the scientific progress that you made over the years, and will understand the strategy of the company, but how much more instructive it is to hear it lucidly explained from the horse's mouth, as we say. And I thank you for your time to give us that your viewpoint and to tell the story, which is only just beginning after 12 years. And I'm sure it's going to go a lot further. We heard on Wednesday from a Swedish, the founder of a Swedish company by the name of Cortus Energy, who have been working similarly like you for many years to be able to produce hydrogen from solid biomass. And what I thought is interesting, the last word in his LinkedIn profile, so he explains all about the company and what they've done, and the very, very last word, I'm wondering if you can guess what it is. Mark.
I'm sorry, I was reading all the questions coming one after the other on the chat, and I missed a sentence.
Okay, we had a presentation on Wednesday from Rolf Ljunggren of Cortus Energy in Switzerland, who has also been working for many years in a different pathway, but to try and achieve hydrogen from solid biomass, which he's now succeeded in doing. So on his LinkedIn profile, he explains all about the background to the company. There's one word at the end. I'm wondering if which I think relates to your story. I'm wondering if you can guess what it is.
I have no guess.
The word is.
I hope it's positive.
It's endurance.
Oh yeah, it took a lot of endurance, and it's not finished at all.
Exactly. I thought that would ring true with you. Okay, perfect. Well, thank you very much, and well done for having that endurance, and now you'll be able to develop that into something really successful.
Thank you, Paul.
So Mark, thank you very much. We will now ask Serena, who is very much involved in research as well, like you have been and continue to be, and is involved in a project, a European project called Agrimax, which has at its heart also the how to realize value from agricultural co-products. So Serena, with those very brief words, I shall pass. Mark, maybe you could just switch off your video at this point, and Serena, I will pass the microphone.
Good morning, everyone. Thank you, Paul, and thank you to the organizer for inviting SICA to this talk. So, yes, I'm Serena, I'm a researcher, and I'm involved in the packaging research in SICA, which is a research institute with the specific aim of promoting technical and technological progress in the food processing industries. So we are involved in other many research projects, but today I'm going to show you one of them. So let's start sharing my screen. Okay. Okay, so in this presentation, I will illustrate to you the progress of the Agrimax project. Agrimax is a very ambitious project funded by the under the BBI Horizon 2020, and the specific aim of this project is, as Paul said, is the valorization of crops and food processing waste, applying a biorefinery approach and also a cascade approach. So just to start in a different way, I will show you the project overview, which contains the goals and the expected results through the official video of the Agrimax project, available on the YouTube channel and also on the website. Okay. So, sorry. So just a few words about the consortium of this project. So we have 29 partners in this consortium. 11 are RTDs, 18 are SME or large industries. And in the entire consortium can cover the whole supply and value chains of the expected sector to be reached. So, okay. As seen in the presentation, in the video, the main goals of the project are to demonstrate the technical and economic feasibility of the combined flexible biorefinery processes by the valorization of crops and food processing derived from food processing waste, and also maximize the economic and environmental sustainability of the Europe agriculture and food sectors, providing, as said, new biocompounds to apply on different sectors as food, packaging, and agriculture. With this purpose, two biorefineries are built. One in Italy that can process tomatoes and cereals byproducts and waste, and one in Spain that can process olives and potatoes byproducts and residues. The important thing of these two biorefineries is that they are flexible, and that means they can process this type of byproducts by sharing the same equipment. So there is no need to build several biorefineries to process this type of byproducts and to obtain with the suitable technology the molecules and substances of interest. So it is also important, this flexibility, because future purpose of this Agrimax project is also to process additional byproducts and residues different from the one actually processed. This second part of the talk focused more on the Italian pilot plant, in which SICA is mainly involved in the processes of the extraction of the residues. The Italian pilot plant is located in the north of Italy, and specifically by a farmer who collect tomato byproducts and also produced biogas through agricultural and food waste byproducts and waste. This Italian pilot plant of Agrimax is an improvement of the previous pilot plant already designed and installed in this location by a previous project. This previous plant can only process the tomato byproducts. In this case, with the improvement of the pilot plant, the type of byproducts processed are increased, and also the quantity of residues processed are also increased. Tomato is one of the byproducts treated on this pilot plant, and specifically peels and seeds, in this case, are separated. From peels can be extracted cutin and lycopene through a cascade approach, while from seeds are allocated to biogas production together with the waste generated by the processing of the tomato peels. The cutin is a substance of polyester type mainly composed of fatty acids as building blocks. This substance can be extracted from tomato peels and can be used by additional treating as a building block of a biolacquer. Biolacquer intended to cover, protect metal food packaging. At this stage of the project, we increased the productivity of the cutin, and this allows to produce the cutin biolacquer on an industrial line at the same industrial level, we can say. And after this step, also the application and the production of metal cans has been possible on industrial line thanks to an industrial partner that can perform this activity. So we reached about the production of about 6,000 cans of half kilo size, and about 10,000 cans of smaller size cans, as for example the one used for tuna. The lycopene is extracted, as said, through a cascade approach from the peels discarded from the previous process. So this is an additional valorization to tomato byproducts. Here, for this molecule, we started from a laboratory scale and we achieved a pilot scale that can process about 40 liters per batch of extract. The optimization of this process is still ongoing and under evaluation, but we have promising results because each time we can improve our yields of extraction, which is the main goal of this type of extraction. The lycopene, as you all may know, is useful for food application, and in this case is will be applied as a food colorant to furnish the red color, as you all know. Also, tomato culture fruits and plants are used in this plant, so we don't waste anything from tomato, and from this waste, compost and hydrocompost are produced by the know-how of the University of Almeria, one of the other project member. The compost is solid fertilizer, and it is made, as you can see in the picture, with the residues of plant and cult fruit, and it is prepared by the composting process. At the end of this composting, part of the compost can be processed to prepare the hydrocompost, which is a liquid fertilizer, mainly composed of humic substances that can improve the plant growth and act as a biostimulant for the plants growing. Concerning the cereals, specifically, we used wheat bran. From wheat bran can be extracted active molecules or molecules of interest for different sectors. In this pilot plant, ferulic acid is extracted, also fibers and proteins. Wheat bran can also be used as it is to formulate composites. In this specific case, by the know-how of Mogu, another partner, the wheat bran are used as a substrate for the growing of mycelium and to prepare are biocomposites that can be used as packaging, as can be seen in the picture, or as pots for the agricultural sectors. The fibers obtained as byproducts of the wheat bran processing can be also added to biopolymers for the production of biocomposites. For example, Agrimax selected to produce pots for the agricultural sectors. In this case, several percentage of fibers added to different bioplastics, biopolymers, are used for the preparation of the formulation of the pots you can see in the picture. The technology used for this type of prototype is the injection molding, available in femto engineering and by the know-how of INSTM. At last but not least, the ferulic acid, which is extracted with the know-how of the University of Bologna, is extracted, the ferulic acid, by a chemical process. A chemical process that can we can obtain the molecule indicated in the picture, which is used as a building block for the production of biopolymers. Biopolymers that can be used for their mechanical properties in the packaging sectors. The ferulic acid could be also used for its antimicrobial and antioxidant properties. In this case, can be used as additives in food applications. To continue the valorization of the byproducts and to continue the activities of the biorefineries, the project developed a platform, which is a very ambitious platform, a tool that can make a connection, a network between a stakeholder and the biorefineries. This platform is a tool that can help farmers and food industries to dispose their waste and byproducts. The biorefineries can manage a supply network of agricultural and food industry waste providers, and to function as an intermediary online market of these byproducts, helping to meet the supply and demand. This platform will bring together stakeholders, creating a networking with the biorefineries in order to guarantee their operativity at maximum capacity all year round, avoiding the seasonality of the products. And if you are interested, you can check on the website or contact Iris as a coordinator. So this is more or less what in this project are going on, and hope this can be helpful also for everyone and for Europe sustainability. Thank you for your attention.
Thank you so much, Serena. Thank you very much indeed. And from what you presented, we can really see the approach is about optimizing in many different streams these agricultural co-products. So congratulations for that, and keep up the good work.
Thank you.
And it doesn't take much stretch of the imagination to imagine the potential for such a process being in Italy. I imagine there's a few tons of tomato peel around to be put through such a process.
Yes.
You'll be able to lacquer a very big tin.
Thank you.
Okay, Serena, thank you very much. So we will now ask Mark Brady of the Corporation Agricole to tell his story, which I know is going to be equally fascinating. Mark, I pass you the mic.
Okay, so good afternoon, everybody. Thank you very much for inviting me to give this presentation. I'm delighted to be here with you today to be able to present our project to you. In other words, what we do is use biomass in order to design biosourced materials. So my name is Mark Brady. I'm a farmer and I'm also a breeder, and I work in the northeastern part of France. And my role today is to represent my colleagues at the board of directors for our cooperative organization. And as such, I preside over the bioeconomy committee. And this is basically the reason why I'm here with you today to present to you our COLSA project, our Rapeseed project. Ours is a cooperative that is particularly interested in this subject, and we have a specific approach that I'm going to go into detail on, a mindset that underpins our project. So here, what we have done is gradually comprised blocks of concrete based on what we call colza straw. What we've been able to do is adopt two different approaches. First of all, we've produced these insulating blocks that can replace traditional building blocks. And secondly, we've produced a second type of block, and these blocks can replace traditional rock wool, for example, or glass wool. Now, above all, I think it's important to note that the use of biomass in the concrete sector it really is becoming reality in Europe. Now, more and more we see a lot of byproducts being used in this sector, but it's important to note that new forms of biomass gradually appearing. Lots of experiments are being carried out, for example, on this rapeseed straw, or also on linen straw, as we might call it. Now, what led us to show a particular interest in the construction sector and in the different types of concrete? Well, basically, concrete, initially speaking, is a mixture of different granulates. You've got one of the materials is going to be cement, for example, and the other is lime. And the idea is to replace these minerals by some products of plant origin. So replacing gravel by soil, basically. And there are specific properties that we are able to provide thanks to the raw materials we can produce. And this makes it possible to provide heat insulation, good quality heat insulation. And at the same time, we're benefiting from the fact that these products are easier to produce and use. Our plant-based concrete has a positive impact on the environment because throughout the life cycle of the plant performs certain natural activities, among which are the fact that the plant stores carbon. So if you look at a product such as rapeseed, it lasts for about 11 months, not quite a year. And throughout the product's life cycle as a plant, it is capable of collecting carbon, and then it has a positive impact on all kinds of climate issues. So when we then use these plants that contain the carbon, it's an excellent way of reducing our use of non-renewable energy, such as sand or gravel, for example. One last advantage, and this is quite a considerable advantage, if we look at the regulatory framework for 2020, the European Union regulatory framework that recommends what we need to do in the construction sector, we need to focus on more high-performing materials from an energy perspective, and also products that send a lot less carbon gas into the atmosphere. And so as a result, a product such as ours that is very much a virtuous product is ideal, because given the way it performs, given the way it is manufactured, it enables us to rise to the challenge from a climate perspective. So what are the different biomasses that we're able to use that are available on the market? We've split them up into three families. In green, you've got the most well-known family, wood basically, and hemp. These are the ones that spring to mind immediately. However, given the research work that is ongoing, consequentially, there's now a lot more use of these products on the market. So we then have a second family. These are what we call the fibres that have a good future. These are cereal, straw, rapeseed straws, and also linen, oily linen straw. All of these products are gradually being used more and more. But let me say that the sector is not quite as mature as it needs to be. It's only in the process of being structured. The third family is what we call the potential fibres. These are the ones I believe that have a great future ahead of them in terms of biomass. A lot of R&D work is going on at the moment, but a lot of the work has not yet been valid. We're not yet 100% sure of the industrial and commercial interests of these products or how we're going to be able to use them in the future. So what made us make the choice of using straw for plant-based bricks? Well, look at this map of France. I do apologize. This is not the weather report for your weekend. We're not demonstrating that you're going to have a sunny weekend. No, this is a map that gives you a clear representation and the representativeness of the amount of rapeseed that grows across France. Where you have dark yellow, this means that there's a lot of rapeseed that grows in the different farms in the region. So as I said earlier, I'm located in the northeastern region, and we can see that north of the Loire, there's an awful lot of rapeseed that grows. So today we consider that if we look at the potential for the annual production rate, we say it's 3.5 million tons. And if we look at the real potential for usage within the scope of our project, we believe it amounts to roughly 1 million tons. So our Rapeseed Project, we believe, it's a project that involves lots of stakeholders, local stakeholders and a lot of cooperative farms. This type of cooperative approach means that it's up to the different farmers to become shareholders, clients, and also suppliers. So within our cooperative, what we look to do is structure all of the different markets. And within the scope of the project that we have, we've decided to work with two cooperatives, Ceresia, that brings together 4,400 farmers, that goes from the upper part of France, the Lille area, right through the northeastern part of France. So basically, it means that today we have the possibility of bringing together many stakeholders for the production of the raw material that I've been referring to. In this sector, and for this project, we have also started to work with a certain number of professional specialists, and our project is now split up into 3 phases. The first phase was the one whereby we wanted to check, initially speaking, through our mapping process, that we call Cartopai, that it was possible to identify all of the resources that would be readily available as straw. So here we're talking about cereal straw, but also this is used a great deal, as we know, for breeding. But this wasn't the case for rapeseed straw. Rapeseed straw was not used apart from being fed back into the soil. So once we did all of this mapping work, and I'm going to give you a few figures.
So then we moved on to the second phase. So now we've got the reservoir, the source. We wondered what we could do. What were the virtues of the plants that we had in front of us? So we tried to imagine different uses, how we could create value from the rapeseed straw. And that's how we looked into different plants. And we're now finishing the third phase of the project. We're working on the formulation of the concrete blocks. We're looking at the formula to be used. And we're also working on a small production unit that has allowed us to test things out and validate the behavior of the concrete walls in a controlled environment to see how the product behaves. So there's a fourth phase, so industrial development of the concrete block, with all of the organization that involves, so that the project becomes an economic reality. So there are 3 major challenges behind this. So we've broken them down as follows. The first challenge that we have is an agricultural challenge. We have to be able to use the biomass for this kind of project. We need to be able to source it. So we've got to have a foot in the field. And the second challenge is that when we're taking the straw outside of the field, this mustn't negatively transform the future soil. And also it's important to have contracts between the producers and the industrialists using the straw. There needs to be some form of contract, something binding about the price and the volumes and the ability to continue production over time. So everything had to be created in terms of production, the crushing machine, the formulation to make the concrete blocks, but taking into account, of course, variability in terms of raw material. The straw as a raw material, it is something that changes and it needs to be managed properly, because we're talking about something that is industrial. We're converting it industrially. The last step is that of commercialization. So this starts, of course, first of all, by carrying out technical assessments to make sure that what we're doing is recognized properly. And then, of course, it involves setting up the first projects, the pilot projects, to try out the technical feasibility and to check that we are meeting market expectations. So to do this, we've decided to work collectively. All of the partners didn't want to be alone with this project for several reasons. First of all, with this kind of project, it's important to be able to supply a considerable amount of material. If we want the product to be developed in the future, you've got to industrialize the process. And this is so that the production costs are in line with market needs. So if it's just a small scale, the product will always be more expensive than the basic commodity. The second reason for working collectively is to share risks. You know, in research and development, it helps to pool costs. If each person was working alone in their own corner, they would have to bear the costs alone. And finally, it's important to have partners who have know-how that you don't have yourself. This means it's important to have professionals for each step of the way. So the next slide explains something that's important when we're talking about biomass, and especially straw biomass. So if we were to compare with sand, it's a stable element. It's to be found all year long in the same place. It's not the same thing with straw. As I explained, straw varies. It's a living organism. And it's not produced all year long either. It's produced during harvesting when farmers work in their fields, they collect the rapeseed, and then there's travel and storage. So it's the only time in July and August when you have this straw produced. So this means that the production unit can then be fed over the course of the year once the straw has been stored properly. So rapeseed is in fact a plant that can compete with other plants so other plants that the farmer is growing. So it's important to be able to have a certain durability in the terms of supply to the production unit. And this is what an agricultural cooperative's job is. It's important for it to have a good relationship with the farmer for this. So the straw comes from different places. There isn't just one production site. So the straw can come from all over the area. But there are also pedoclimatic factors that have to be taken into account, because that can have an effect on the production of straw. You know, as we're talking about a living organism, and there's only one harvest a year. And another thing that I'd like to share with you, which seems to me to be essential, is that when we launched the project, we wanted to make sure that the impact of exporting straw would not be to the detriment of the soil. As I said, rapeseed straw is not used very much today. And that's why the rapeseed straw stays in the field and feeds the soil. It provides fertilization. And so it's important, and I'm talking to you as a farmer, it's important that this does not create an imbalance in the soil if you take too much straw away from it. So we did an awful lot of work with a modeling tool to confirm that by exporting straw every 6 years, we do not harm the balance of the soil. And if you look at the photograph, this is a guide that we drew up for our farmers. This is so that they can choose which plots they can use to extract the straw. So this is the role of the cooperative again, to be a stakeholder that is able to guide people along the construction of the project. So we are responsible stakeholders, and we're responsible for working properly with all partners involved.
Mark, many thanks. An exemplary project that you have developed there. And I feel certain that all of your listeners will have understood very clearly the message that half of the story is the scientific breakthrough, but equally as important is the methodology and the understanding of the market needs, and building your project around that, structuring it, collaboration, finding the right set of skills that will realize the aim of the project to reach its conclusion successfully. So you really explained all of that very well, and that approach that you've taken has led you to where you are, well, we could all hope to have your concrete in our buildings in the future. And the question of sand, I think, is also an interesting one, because as this is also a limited resource, and we've been using so much of it that if there's a substitute for natural sand by recyclable agricultural co-products, then that is an additional benefit, another additional benefit. So fantastic, congratulations, keep up the good work as well. So I'm sure there'll be some more questions to come. As I said, time is running on. We still have another 20 minutes, so we're doing fine. We did have another presentation from Biofabric Solutions that was due, but as I said, it won't take place as we imagined it. We might be able to, we'll try and find another date, because it would be a shame not to hear from them in person. But just to substitute, I'm going to share my screen with you. We're going to see a video which is on their website. Everybody can see that correctly now? Yep, okay. So what we have here is, as you can see, we're in a agri recycling renewable context, and it is a containerized, scalable solution to be able to take grass, cut grass, as well as other biomass feedstocks as a biorefinery approach in order to have a different kind, to go back to the molecule and have from there different pathways available to valorize this biomass grass waste or grass co-product, I should say. So I'm going to play this video. It is in English. There are subtitles, no, sorry, it's in German, but there are English subtitles. But as I say, we will try and get Biofabric Solutions back to another webinar, and we will let you know I hope in the next 2 weeks when that will be taking place. 3 different projects that have at their basis the valorization and recovery of value from different kind of agricultural co-products. I would just like to ask you, first of all, I mean, obviously, many of these approaches that you have are market driven in terms of there's a need in the market to replace fossil derived products with bio-based substitutes. In terms of where this whole movement is going in the future, what do you see as the key enablers beyond market requirement? What are the key enablers that can make us move faster? Because as we know, with climate change, it's now that is important. It's not waiting another 10 years. It's making these changes as soon as possible. So would you maybe be able to provide an idea of what you think the key enablers, seeing as this is your day-to-day business, what would be the key enablers to help this whole movement of bio-based move faster? Would anybody like to start?
Well, maybe I could start with the vision from the specialty chemicals. So as I told you, we focus for the go-to-market approach on the cosmetics, and I see that what has been really triggering the change in this field is the claim from the leader of the domain, L'Oréal, that they would move to bio-based products entirely, with a clear horizon pathway. So they said 95% biosourced by 2030, and by doing so, they have forced all the other players in the field to align on their vision. And what happens is that the whole field is going to move to biosourced pretty much at the same time. They created the movement, and so I see that maybe the answer to what is the trigger can be, and the answers could be that financing from the states is important, that regulatory is important. That's all true. But in my opinion, what is really major is solid and concrete claims from the big industrial players that are enforced eventually. And this really makes the difference.
I'm gonna draw a parallel, Mark, with Tuesday's sessions on sustainable shipping, on moving towards net zero, whereby industry bodies aim to achieve 50% reductions in CO2 emissions in shipping by 2050. Yet we see the world's largest shipping company, Maersk, announcing their first net zero build ship has started and will be operational, should be operational by the end of 2022, end of 2023, 7 years ahead of schedule. And it's these kind of, that's a parallel that can be drawn with L'Oréal in terms of leading the pack and dragging everybody else with you. It's a bit like when Kellogg's used to do an advert for cornflakes. It brought everybody else. Everybody bought more breakfast cereals because the leader gave it prominence. So it's interesting to hear you say that, and that is reflected across other sectors that are trying to decarbonize or are trying to move in one way away from fossil-derived sources of energy or products. But Serena and Mark, how would you like to reply to this question?
Just to add something that, yeah, the challenge of this type of project, this European project, is in fact to go to the market. So it's the big challenge, and in this project we try to involve also the end users of this of the composites, of the prototype that we are intended to formulate. So the industries that
Yes.
must be interested in this, in the application of this biocomposites, biocompounds, and so on. And also, in this case, farmers and processing industries. So the source of the feedstock that can be used for the production of the biocomposites should be involved in this chain, in this value chain. So all the stakeholders in the value chain should be involved. This can be used, this can be done by communication. So this is fundamental. And for this reason, the stakeholder platform was designed, this tool was designed to try to create a connection and make farmers, industries, and users aware of this possibility. Just to know that, yes, we are processed by products, waste, we create, let me say, a new compounds, molecules that could be used for another application that can be then can be used in the market, on the market, but this is only possible if everybody collaborate in this chain. So
those are two key words that have run throughout the 5 days is collaboration. Yeah. Innovation and collaboration. Nobody it needs those two elements in order to get to the successful outcome. Yeah. As the three of you also have stated. Yeah.
Also, a legislation should be near this new topic, because biocomposites from waste must be regulated. So there are no clear legislation about this also. So
right. Okay. Perfect.
Many
okay.
people,
well,
many people should be involved.
Well, thank you for that viewpoint. That's and Mark, there's also a question for you directly in the chat. I don't know if you want to pick up on that, but give us your viewpoint firstly on this question of enabling. What is going to enabling for bio-based products in the future? What's key?
Vous pouviez me traduire, s'il vous plaît. Je sais plus rien.
Ah, bah, je vais le dire en français alors.
Marc, you need to switch channel. Il faut changer de canal, Marc, être sur le canal français.
Les biosourcés, ça avance. Il y a des projets comme le vôtre. Il y en a d'autres.
There are many projects like yours. What needs to happen?
Ça devient quelque chose qui est plus dispersé, qui est dans le quotidien de tout le monde en fait. Quelles sont les clés pour que ça se développe?
What are the keys for it to work?
Alors, pour moi, il y a
well, as far as I'm concerned, there are two angles here. As a producer, there's a production angle. So you need to find the right kind of balance. So for biosourcing, you have to have a balance. This is what I mentioned in my presentation, in fact. You need to have the right soil balance. So you need to, if you're doing something to the soil with your production, then you're not ensuring this balance for biosourcing. So the first step is to check that you have that balance and that you're in line with that. So then with respect to the market, you'd need to have scarcification of the other products and awareness that, you know, there's everything to gain in our planet. And people need to change the way they consume. You know, the concrete that we're talking about is not traditional concrete. So it's important to explain that as well as its use virtue,
C'est-à-dire
pour l'interprétation.
et comment je fais ça?
Il y a un petit globe en bas sur votre écran. Si vous descendez le curseur, vous avez un petit globe interprétation.
Il faut que ça soit
You can
désactivé.
hear the translation.
Et donc là, il est écrit désactivé. OK.
OK.
Est-ce que ça va mieux?
Allez-y, parlez, on va voir ce que les traducteurs.
D'accord. Donc, je disais, vous m'avez coupé dans mon élan.
Start again. Recommence.
Ah, je recommence tout?
Non.
Non. C'est de montrer justement les propriétés, les caractéristiques que le produit naturel ou historique, traditionnel, n'apporte pas. C'est ça qui fera que la prise de conscience, eh ben, quand j'aurai à choisir entre un béton traditionnel et un béton végétal, j'utiliserai plus facilement le béton végétal.
Between a traditional concrete and another form of concrete, a natural concrete. So to use it as an insulator for their building. It has, so the consumer chooses it because it has environmental virtues. Therefore, it is a virtuous purchase. So this awareness is essential. It's necessary. And I think that the objective, so between now 2000 and 2030, that is to achieve carbon neutrality. So this is something that's going to push us as citizens. We're going to move towards this kind of use. Today, they're only just emerging. So we are in our field. We are just at the beginning of the use, of the industrial use of this kind of product. So it's normal that, you know, there's a lack of communication, a lack of knowledge about this. So we need